Have you ever wondered what's going on inside Celestia? Who's hanging out in there? What are they doing? And more importantly, who are they doing it with? Thankfully, we have the Celenium API to give us all that juice. I'm going to show you how to leverage AI on top of it to give us the gossip we're looking for. Let's go. This is what we're going to build. Firstly, we have a form which gets some parameters from the user, like how many transactions it should analyze further, as well as the minimum transaction threshold it should filter through, so that we don't get transactions that are so small that may be irrelevant to the type of market analysis that we're trying to make. So we generate the report, and we can see some fun loading state as we're going through it. And so as you can see, we get a bit of a summary, some market trends, maybe some noteworthy transactions worth reviewing, as well as all of the transactions that were reviewed with its links so that we can review them further if we'd like within the Celenium API Explorer. Let's get into my favorite part, the code. So as you can see, we're doing a Next.js application where we have first our application folder. This is the one that contains our page TSX, which is where our single page application will live. We also have an API folder, which handles our server-side components. This is where we'll be calling on our Selenium API to fetch for transactions, as well as where we're calling for the OpenAI API to get those market insights. We also have some components. We are leveraging Shadcn for some front-end components for nice, easy prototyping, as well as some custom-built components that will help us generate that UI for the user. And of course, we're setting up some types to make sure that we're enforcing typing through our application. To kick things off, I want to dive right into our Selenium API endpoint. First thing that I want to bring some attention to is our Selenium API base URL. Now, in this case, calling it in from our API mainnet, but of course, keep in mind that you may want to just add in some environment variable and switch up this API base URL depending on the network that you want to fetch from, be it more like a testnet like Mocha, or if you really want to use a mainnet, of course, that as well. Additionally, another key component of this file is our endpoints object. In this case, I'm only calling in to get for transactions, but of course, there is a scenario where you may want to have this object contain a bunch of different endpoints, which is why I've strategically left it as an object rather than a string. If you go into our Selenium API docs, which I definitely recommend that you do, you'll be able to see that not only are there the endpoints here, the URLs, but there's also a big variety of endpoints that are entirely free that you don't need to pay for, and which require no authorization. So definitely make sure to leverage those. You'll be able to see all of the different endpoints that you can get. For example, there's some cool ones like the search endpoint. There's some stats already pre-generated for you. You can get namespaces, you can get blocks, you can get addresses, you can get validators, or of course the one that we're leveraging, which is the transactions endpoint. And it also enables you to call it directly from the UI, so that you can see how not only the parameters that you're able to use, but also how the different responses change if you switch up the parameters that you're leveraging, and the exact data types that you'll get. So definitely play with this if you have some time. I would recommend doing it before dabbling into the code. Now, back to our Selenium API page. So as you can see, we're setting up a GET request, which will get all of the transactions from the Selenium API. Now, the first thing that we do is that we set up those parameters. These parameters come from the URL request that we're calling in, and we're using it to determine the parameters for our search. So this is the area where we set those up. What we want to do is really leverage Axios to call on that transactions endpoint using those parameters, and then rearrange the data response that we get so to showcase us to the UI in the way that we want it to, and of course handle any errors that may come about. Now, this is really where we're gathering those transactions from the Celestia blockchain, and you can see how we use that request in different forms here. So, for example, if we wanted to fetch the high-value transactions, what we would do is we call on our API transactions route, and we pass it in through the URL exactly the parameters that we'd want to leverage on our request. When that transaction goes through, it just returns the JSON, otherwise it catches on the error. We do the same thing. We want to fetch these staking transactions, except now for the parameters, we want to make sure it's passed at the type stake so that we only get the transactions that are staking transactions. Now, the way that this is being used is within our home, right? So in our home component, what we have is firstly, some state handling. I won't dive in too deep into the front end since a lot of it is just style, but the state is important. So first, we set up both the transaction state as well as the staking data state, as well as our insight state, which is the one that will hold the information that is returned from the OpenAI API that I'll show you in a sec. We also have some like interactivity state, as well as this form state, which is the one that we'll use when we're doing the requests. Now, what is happening in the UI is that based on those states, we're displaying different information, right? So if it's loading, then show up the loading state with some fun messages to make sure that the user is not bored while the AI is thinking. We also have a nice error state. And then, of course, we dive more into the interactive portion that we care about. So if the form has not been submitted, what we want to do is then display that form that is requesting that information from the user. This is a component I created, which has some input fields to ask for the amount of transactions that the API should fetch for, or the minimum threshold that we should look at. And so, of course, when this button is clicked, which is the generate report button, then that's calling on our onSubmit function passed over when we're calling on the component. That is the handle submit function that we established on this page.tsx home file. And the first things that we do are just classic HTML interactivity, but really where the magic is happening is in this fetch data with params function. As you can see, we're passing over the transaction count and the minimum transaction value that we set up in our previous form so that we can use it when we're actually fetching in the transactions from the Celenium API. If we dive into the code, first we fetch on those high value transactions, then we fetch those staking transactions. We set those up as the values of the state that we've set up, we defined below. And then we actually call in our API insats route, which is the one that calls on the OpenAI API to get those that market analysis. Now, a key component here, before the response is even set as the insights that we'll see in the UI, is that we have a body which includes the transaction data and the staking data that we received from our Celenium API. And so when we dive into our API insights route, what we can see is that really we're calling in our OpenAI package and generating a client, of course, by keeping our API key secret. Please make sure to use some dotemp or another package and never hard code your API key. What we want to do is set up a post request to the OpenAI API to generate a chat completion for our market analysis. So firstly, we want to validate that the data that we're getting for our request is what we expect. From that data, we want to decouple our transactions and our transaction data. This is what we passed on over in our body when we were doing the request. Make sure that it's coming as an array, make sure that it's not coming as empty, and then we use that information within the prompt to give it to the OpenAI to generate our market analysis. As you can see, I really like making prompts robust, giving it examples, giving it some pointers of things to look at, maybe even some formatting things like adding an emoji, comment in markdown format, and different things that will make sure that the report is exactly as I expect it. Then this is really the most important part of the OpenAI API is using their chat completions API endpoint and establishing the model that you want to leverage with the maximum amount of tokens so that you don't go over, a rate limit, and then passing it in exactly that prompt to make sure that you're generating that response and passing it over to the UI. So once we set up that data as the insights that we're displaying, what we can see in our front end is that we're just using React Markdown, which is a package that enables me to turn Markdown into HTML so that React can easily read it and enjoy it with nice styling. and showing it to the user here with some specific styling rules that I've enabled through Tailwind. So that is it. Underneath, we have the table of the high-value transactions and the staking activity that was queried merely to showcase the user the information that was used to generate those insights. But as you can see, just with one API route, calling on the Celenium API to fetch all transactions and passing those transactions as part of the context and the prompt that we're passing over to the OpenAI API, we can easily have a very interesting market analysis of the Celestia blockchain in only a few minutes. Talk soon!